Hey students, welcome back. We're into section 1.6, and this section, as I told you, is solving limits using algebra. And this is going to be a big way for you to solve limits once you get familiar with it. Your book lists 11 limit laws for solving limits algebraically. Here's the first 5, and they're kind of to be expected. The limit as x approaches a is just some value of x that's being approached. The limit as x approaches a of f of x plus g of x equals the limit as x approaches a of f of x plus the limit as x approaches a of g of x. In other words, a limit of a sum is equal to a sum of two limits. Likewise, a limit of a difference is equal to a difference of limits. Now this third one right here is used all the time. All the time. Limits are the basis for derivatives, and we use this all the time in derivatives. Use it all the time in limits. If you have the limit as x approaches a of some constant times a function, you can pull the constant outside the limit. You'll use this all the time. All right, these are a little more surprising than maybe these, but they hold true. A product of limits is equal to a limit of a product. Or a limit of a product is equal to a product of limits. And this one. The limit of a quotient is equal to a quotient of limits, assuming that the limit denominator does not equal 0. Otherwise, the limit law doesn't hold. All right, so let's just look at a quick example of what this might look like. Here's two functions you're familiar with. This function f of x equals x plus 1 squared. If I asked you what type of function it is, you'd say quadratic function. If I asked you for the shape of the graph, you'd tell me an upward parabola. And since there's a plus 1 inside the function, the graph is shifted to the left by 1. And g, the g function right here, g of x equals 3e to the x. If I asked you what the graph looked like, you would tell me, well, that's the graph. It looks like this. It's an exponential function. That's its type. It's probably the most used type of exponential function, base e raised to the x, e to the x. 3e to the x in this case. Okay, let's test these limit laws out. This first one right here. The limit of a sum is equal to the sum of limits. Let's just test it out the numbers, shall we? Here I have x approaching 0. What do you do when you do this approach algebraically? You plug in. Okay. 0 plus 1 is 1. 1 squared is 1. E to the 0 is 1. Any real number raised to 0 is 1. So you get 3 times 1, which is 3. 1 plus 3 is 4. So the left-hand side equals 4. The right-hand side ought to equal 4 in all cases. As x approaches 0 of x plus 1 squared. Again, you plug in what x is approaching into the f function to find out what f of x is. Well, that's going to be 0, so you get 1 squared, which is 1. Here you plug in 0. What's 3x to the 0th power? E to the 0th is 1 times 3 is 3. 1 plus 3 is 4. 4 equals 4. We're good to go. The same would hold true if I put a minus sign here and a minus sign here. Now I would get 1 minus 3. And here I'd get 1 minus 3. In either case, I'd get negative 2. All right, let's try here. The limit as x approaches 0 of 5 times f of x. Again, if you have a constant in front of a function, what do you do with the constant? Pull it outside the limit. Great. Pull it outside, you get 5 times the limit as x approaches 0 of x plus 1 squared. Let's test it out. Plug in 0, you get 1 squared, which is 1. 1 times 5 is 5. Here, plug in 0, you get 1. 5 times 1 is 5. 5 equals 5, we're good. Third limit law. Fourth limit law right here. Limit of product equals product of limits. No problem. Plug in 0. What do you get? 1, 3. 1 times 3 is 3. Plug in 0 here, you get 1. Plug in 0 here, you get 3. 1 times 3 is 3. And Not remarkably, plug in 0, you get 1 over 3, which is 1/3. or you can take the limit here, you get 1, take the limit here, you get 3, which is 1/3. These limit laws will hold for every case here, with the only exception being this right here. There are 6 other limit laws which I'll be discussing with you.
Sure, folks, I'm back. I'm not at school anymore. Now I'm in my own home, in my daughter's bedroom, which is now my home office. So let's see if this kind of makeshift whiteboard works for us. Last we talked a couple seconds ago. You were looking at limit laws. Look, the first 5 limit laws with me. It kind of seemed intuitive. Well, so are the next 6 limit laws. So let's look at them together, okay? Number 1, the limit as x approaches a of a function f of x raised to the nth power is equal to the limit as x approaches a of f of x to the nth power. The limit of a function raised to a power is equal to the limit of a function raised to that power. Kind of intuitive. Let's look at an example. As x approaches pi over 2, what will sine squared x approach? You have to remember that sine squared x is a shorthand for sine of x, the whole thing squared. So this is where the limit as x approaches pi over 2 of sine of x, the whole thing squared. Okay, so if we plug pi over 2 into that, what we get? Sine of pi over 2 is 1. 1 squared is 1. So this limit is 1 on the left-hand side. On the right-hand side, well, sine of pi over 2 is 1. 1 squared is 1. 1 equals 1. Again, intuitive. This is the key. This is the key. Number 7 is really what all this comes down to. Because everything else is just, hey, plug and chug. So if you get 7, you're good to go. Let's look at 7 together. The limit as x approaches a of c equals c. What's c? Just some constant, some real number. Here's an example. As x approaches 5, what does f of x approach? 13. As x approaches 5, 13 approaches what? 13. What? What am I talking about now? You have to see this right here as a constant linear function. Look, I want you to envision it over here. This thing right here is a constant linear function. It's not a sine function raised to a power function, right? It's a constant linear function. What does a constant linear function look like? Like y equals 13 or f of x equals 13. It's just a straight line with a slope of 0, right? So, think about this. As x approaches 5 from both directions, what is f of x approaching? Is it going up or down? It's not. It's just staying at 13. As x approaches 5 from either direction, y value, f of x value, is 13. That is so crucial. As x approaches 5 of 13 is 13. In other words, if there's no variable here to stick 5 into, just go with what's in there, because it's a constant linear function. I hope that makes sense to you. This is key. Everything else should be intuitive at this point. As x approaches a of a linear function x, well, we just plug a in for x, and what do you get out? A. Here's a power function. Plug x into a, and what do you get? A to the n. Plug x in for the nth root of x, what do you get? The nth root of a. And this right here is just this guy up here. Because remember, f of x to the nth power, if the nth power was, say, 1/2, that would make it a square root effectively, wouldn't it? So that's what this is saying. As I say, the second root of f of x, that's the same thing as saying f of x to the 1/2 power. So this rule holds, then number 11 holds. Limit as x approaches a of the nth root of f of x equals the nth root of the limit as x approaches a of f of x. Okay, so it's basically here's what all the limit laws come down to. You plug in a in for x. Whatever x is approaching is what you're going to plug in for the x variable in f of x. And whenever you have a constant, whenever you have a constant over here, it's a constant linear function, so no matter what is happening over here, f of x is approaching that exact value. Okay, thanks.